All right, everybody, welcome back. Today we are diving deep into a listener-submitted topic, and one that I have to say is super interesting to me too. We're talking about the Goldilocks zone, the area in space where conditions are just right for life, at least the kind of life that we know anyway. But today's deep dive is all about how the discovery of chemosynthetic life right here on Earth has, kind of shaken up our understanding of what just right actually means.
Yeah, definitely.
And to guide us on today's journey, we're turning to an article from Zen called Beyond the Goldilocks Zone. And I gotta say, it's packed with some pretty mind-blowing stuff.
Wow.
Like, for example, we're going to be talking about life thriving where you'd least expect it.
It really changes things, doesn't it?
Right.
The article does a really good job of highlighting the shift in our thinking, because for centuries we've been so focused on finding planets that look just like Earth, with liquid water, with sunlight, and a comfortable temperature range. All the things we think are necessary for life.
Right. It's like this cosmic checklist for life. Right. But what if we've been a little too narrow in our search?
Exactly. And that is the question that scientists have been wrestling with ever since the discovery of those absolutely incredible ecosystems, around hydrothermal vents back in 1977.
Oh, yeah, those underwater geysers that are just spewing out superheated water.
Yeah.
And all sorts of weird chemicals. I remember reading about those. They're near the Galapagos Islands, right? Yeah. And it's like pitch black down there. Not exactly what you picture when you think about, a cradle of life.
Right, but life finds a way. Thriving ecosystems, just teeming with all sorts of bizarre and wonderful creatures, giant tube worms, strange clams, all sorts of things that completely upended our understanding of where life could exist.
It's like finding an oasis in the middle of the desert. So how do these creatures survive without sunlight? I mean, that's the basis of life as we know it, right?
Exactly, and that's where things get really interesting. They've evolved to utilize a process called chemosynthesis.
Okay, I'm going to need you to break that down for me.
Okay, so imagine tiny microbes, like acting as little chemical factories, right? And instead of using sunlight for energy, they're able to harness energy from the chemicals in those vent fluids, things like hydrogen sulfide. It's a completely different way of life.
So it's like their own internal power source, fueled by chemicals instead of sunlight. That's crazy. It's almost like something out of science fiction.
It does sound a little bit otherworldly, doesn't it?
Yeah.
But this discovery right here on Earth is forcing us to really expand our definition of what habitable actually means. Like the Goldilocks zone, as we've traditionally understood it, might just be the tip of the iceberg.
Okay, I see where you're going with this. So if life can thrive without sunlight, relying solely on chemical energy,
it opens up a whole universe of possibilities. Suddenly, those icy moons we've been eyeing, places like Europa and Enceladus, they become much more intriguing.
I'm with you. Yeah, we've talked about these moons before. They're both thought to have vast subsurface oceans, right? But they're so far from the sun. It's freezing out there.
True. But remember, now we're not just looking for sunlight as the energy source. Think about it. Those moons could have similar hydrothermal vents, right? Driven by tidal forces and geothermal activity, providing the perfect chemical cocktail for life to take hold.
I'm starting to see those icy moons in a whole new light. It's like the search for life just got a major upgrade.
Absolutely. And there's evidence to support this. Remember those plumes of water vapor that we've observed, like erupting from the surfaces of both Europa and Enceladus?
Yeah, those were big news. Yeah, they suggested those subsurface oceans are pretty active.
Exactly. And that activity, that interaction between the ocean water and the rocky cores of these moons, that could be generating the chemical energy needed to support life.
It's like those hydrothermal vents on Earth, but on a moon-sized scale. So what does all of this mean for the Goldilocks zone? Are we saying it's no longer relevant?
Well, not necessarily. It's more about expanding our definition of what habitable means, Yeah. We need to be open to the possibility of life as we don't know it, thriving in environments that we previously dismissed as, too harsh or extreme.
So we need to start thinking outside the Earth-like box. We can't limit ourselves to looking for planets that mirror our own.
Precisely. The discovery of chemosynthesis is a game changer. It's like we've been given a new lens through which to view the universe, and suddenly the possibilities seem endless.
It's kind of mind-blowing, isn't it?
Yeah.
To think that life might be far more diverse and adaptable than we ever imagined. And it all started with a few tube worms hanging out in a deep sea vent.
It just goes to show nature is full of surprises. And the more we explore, the more we realize how much we don't know.
This is where things start to get really fascinating. And we're just getting started.
And we were talking about how chemosynthesis really challenges our understanding of where life might actually exist. But it also raises these questions about, like, what life might even look like.
It's so true. I mean, we tend to picture alien life based on what we see here. Right?
Yeah.
You know, plants, animals, things that need sunlight to survive. But these chemosynthetic life forms, they're like something out of a sci-fi movie.
It really shows just how adaptable life is,
Right.
right? You know, like they've evolved completely different ways of surviving, of using chemical energy to like build and sustain themselves. It's amazing.
Yeah, it really makes you wonder what other incredible adaptations could be out there, right? I mean, if life can look so different here on Earth, imagine the possibilities on other worlds.
The potential diversity is just, it's staggering to think about. What if there are life forms out there based on silicon instead of carbon? Or creatures that use forms of energy that we haven't even like discovered yet.
Whoa, it's both exhilarating and a little humbling, right? This one discovery just throws open so many doors.
Absolutely. You know, chemosynthesis isn't just about finding new habitats. It's about expanding our whole definition of what life is even.
And it kind of makes you question what other rules about life we might be like clinging to. You know, like what other assumptions could be holding us back from making even bigger discoveries.
Right. That's the beauty of science. You know, it's this process of constantly questioning and revising our understanding. This discovery with chemosynthesis, it's a major leap forward, but it's just the beginning.
So where do we go from here? How do we take this knowledge and use it, you know, to actually search for extraterrestrial life?
Well, for starters, missions like that Europa Clipper mission are more important than ever. We need to get a closer look at these icy moons, you know, gather data, and see if these theories about potential chemosynthetic life actually hold up.
So exploration is still key, but we also need to like adjust our expectations. Right. We can't just be looking for Earth 2.0 anymore.
Yeah.
Exactly. We need to be much more open to the unexpected. Like, what if life doesn't announce itself in the ways that we're used to, you know? What if it's hiding in plain sight?
It's almost like we need a whole new playbook for finding alien life.
Yeah, in a way, yeah. We need new technology, new methods, and maybe most importantly, new ways of thinking.
This is really pushing the boundaries of our imagination. We're talking about like fundamentally changing how we search for life beyond Earth.
And not just in space either. Think about the possibilities right here on our own planet. Like there could be entire ecosystems thriving in our deep oceans, powered by chemosynthesis that we just haven't discovered yet.
It's amazing to think that we've only just scratched the surface of understanding life, even here at home.
Right. It really shows you the vastness of the unknown, you know, and just the endless potential for discovery that's out there.
But this whole shift in perspective also brings up some like really profound questions, doesn't it? Like if life can exist in such a wide range of environments, what does that say about how likely we are to find it in other parts of the universe?
It definitely makes it seem a lot more likely, that's for sure. You know, the universe might be teeming with life, just not the kind that we're used to.
And if that's the case, like what does it mean for humanity? What does it mean for our place in the universe?
Those are some big questions that philosophers and scientists have been asking for centuries, really. But now with this discovery of chemosynthesis, they feel a lot more urgent, more real. You know what I mean?
Yeah. It's not just a thought experiment anymore, is it?
Exactly.
We're not just like speculating about the possibility of extraterrestrial life. We're actively searching for it. And we're doing it with a new understanding of where and how it could exist.
And that's what makes this such an exciting time to be alive. You know, like we're on the cusp of a new era of exploration and discovery, an era that could redefine how we understand life itself.
It's enough to make your head spin, but in a good way. Like we're on the verge of something really groundbreaking.
It's a pretty pivotal moment, that's for sure, in how we understand life and our place in the universe.
And it all started with a few tube worms living in a deep sea vent. Who knew?
It just shows that the most amazing discoveries can come from the most unexpected places. And it highlights how important it is to stay curious, to be open to the unexpected, and to just always be asking, what if? You know?
This deep dive has been quite a journey. We've been talking about how, you know, chemosynthesis changes how we look for life out there. But what if we actually find it? Like, how would we even recognize it if it's so different from everything we know?
That's a really good point. We have this tendency to search for these signatures of life as we know it. So things like oxygen or methane in a planet's atmosphere, those are the things that we look for.
Right. It's like a fingerprint that says, hey, life is here. But what if alien life doesn't leave those same fingerprints, right?
Yeah.
Like, what if their biology is completely different from ours?
It's totally possible that we could be looking right at it and not even not even realize it. We need to develop new ways to detect life, ways that are less Earth-centric, more open to the truly alien.
So it's almost like we need to learn a whole new language, right?
Yeah.
One that allows us to communicate with life forms that could be totally different from anything we've ever seen.
Exactly. And it's pretty humbling, isn't it, to think that our understanding of life could be so limited that we might be blind to other forms of it that are right there in front of us.
So in a way, the discovery of chemosynthesis is kind of like a call to action, right? It's a challenge for us to rethink all those assumptions, to broaden our horizons, and to develop these new tools and techniques for exploring the unknown.
Yeah, for sure. It's a good reminder that we're still just at the beginning of this journey. This journey to understand how diverse and complex life really is, in the universe. And that journey is it's filled with wonder and mystery and just endless possibilities.
Well, you've certainly given our listeners a lot to think about today. We've gone from the depths of our oceans to the icy moons of Jupiter and Saturn, and it's all thanks to the discovery of chemosynthetic life right here on Earth.
And like you said, we've only just scratched the surface. This discovery has opened up a whole new chapter in the search for extraterrestrial life, and I have a feeling we're going to see some truly incredible discoveries in the years to come.
It's a pretty exciting time to be alive, wouldn't you say?
Absolutely, and I can't wait to see what we uncover next.
We started this deep dive with a question. Does the discovery of chemosynthetic life change how we think about the Goldilocks zone?
Mm-hmm.
And I think the answer is pretty clear, right? It's not just about finding another Earth. It's about expanding our understanding of what habitable even means.
Yeah.
And recognizing that life might exist in way more places than we ever imagined.
Yeah, it's about challenging those assumptions.
Yeah.
Embracing the unknown and being open to the possibility that life might surprise us in ways that we can't even imagine yet.
So if life can exist without sunlight, thriving on chemical energy in the depths of our oceans or under the icy crusts of distant moons, what other assumptions about life might we need to reconsider? That's something for all of you to ponder. Thanks for joining us on The Deep Dive, and until next time, keep looking up.